Welcome to the session on trigonometry and modelling, solving trigonometric equations. The objectives for this session are to solve trigonometric equations using the addition and double angle formulae. The angle addition formulae and double angle formulae are given on your screen. We're going to use these to solve our examples. Pause the video and have a go at the example on your screen. Press play when you're ready to view the solution. So let's solve this. If we apply the angle addition formula for sine to this equation, as shown, then we obtain 3 cos theta equals 2 times sine theta cos 60 degrees plus cos theta times sine 60 degrees, which is equivalent to 3 cos theta equals 2 sine theta times a half plus 2 cos theta times root 3 over 2. Rearranging this gives us sine theta equals 3 minus root 3 times cos theta, as shown. And then, dividing by cos theta gives us sine theta over cos theta equals 3 minus root 3. And this, of course, implies that tan theta equals 3 minus root 3. Which is equal to 1.26795. Now tan is positive in our example, and therefore we have that either theta equals 51.7 degrees, which occurs in the first quadrant, or theta occurs in the third quadrant and is equal to 51.7 degrees plus 180 degrees, which is of course equal to 231.7 degrees. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We're required to solve cos theta cos 30 degrees minus sine theta sine 30 degrees equals 0.5 in the interval theta between 0 and 360 degrees. So let's solve this. Applying the addition formula for cos gives us that the expression on the left-hand side is equal to cos theta plus 30 degrees. Here's a graph of y equals cos x. If we want to solve cos theta plus 30 degrees equals 0.5, we're going to take theta plus 30 degrees as being equivalent or equal to x. And then we draw a line at y equals 0.5 as shown. The cos curve and the line intersect at the point x equals 60 degrees. Therefore, cos 60 degrees equals 0.5. The other point of intersection is at x equals 300 degrees. And therefore, theta plus 30 degrees equals 300 degrees also. So we have that either theta equals 30 degrees or theta equals 270 degrees. These are the only two solutions for the interval for theta. Now let's have a go at part B. Using our answer to part A, we are required to write down the solutions of root 3 cos theta minus sine theta equals 1. So let's solve this. Now this equation, when divided by 2, as shown, gives us this equation. This is equivalent to cos 30 degrees, since root 3 over 2 is equal to cos 30, times cos theta minus sine 30 degrees times sine theta equals 0.5. And this is the equation in part A. However, we know from part A that theta equals 30 degrees and 270 degrees. And therefore we found our solutions to part B. Now let's have a go at another example. Pause the video and have a go. Press play when you're ready to view the solutions. We are required to solve 8 tan 2x tan x equals 9 for x between 0 and 2 pi, giving our answer to 2 decimal places. So let's solve this. We're going to apply the double angle formula for tan to this equation. As shown, to give us this expression here. Multiplying through this by 1 minus tan squared x then gives us this expression, and multiplying out and rearranging gives us tan squared x equals 9 over 25. Therefore, tan x equals plus or minus 3 over 5. Let's now consider the cast diagram. When tan x equals 3 over 5, clearly tan x is positive, therefore it's either in the first quadrant or the third quadrant. In the first quadrant, x is equal to 0.54. And in order to find the value of x in the third quadrant, we simply add pi, as shown here, to give us 3.68. When tan x equals minus 3 over 5, clearly tan is negative, and therefore it's either in the second or the fourth quadrants. In order to find the value in the second quadrant, we add pi. And in order to find the value in the fourth quadrant, we add 2 pi. So we have 2.60 in the second quadrant for x, and adding 2 pi to minus 0.54 gives us 5.74, which is the value in the fourth quadrant. Now, since x is greater than or equal to 0 and less than 2 pi, we cannot have x equal to minus 0.54. And therefore, the values of x are 0.54, 3.68, 2.60, and 5.74. Now let's consider another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at Part A first. We are required to prove the identity shown on your screen. So let's prove this. We're going to begin by expanding the left-hand side first, as shown. We group cos squared and sine squared together as shown, and tag on the minus 2 cos 2 theta sine 2 theta at the end as shown. Cos squared plus sine squared is equal to 1, and if we plug in a equal to 2 theta into the formula for sine 2a, we obtain sine 4 theta is equal to 2 cos 2 theta sine 2 theta as shown. And this is equal to the right-hand side of the identity. And therefore we've proved part A. Now let's consider part B. Using part A, we're required to solve cos 2 theta minus sine 2 theta equals 1 over root 2 for theta greater than or equal to 0 and less than pi over 5, giving our answer in terms of pi. So let's solve this. From part A, we have this identity. Notice that what we're required to solve does appear in this identity, and so we can replace cos 2 theta minus sine 2 theta all squared by 1/2. We've simply squared the 1 over root 2 as shown, to give us 1 minus sine 4 theta equals 1 over 2. Therefore, sine 4 theta equals 1 over 2. This implies that 4 theta equals pi by 6. And so theta equals pi by 24. This brings us to the end of this session. If you have understood its contents, you should be able to solve trigonometric equations using the addition and double angle formulae. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.